Assalamualaikum and hi, my name is Hamzah Luqman Rosdi, and today I will explain to you about our assigned experiment, which is experiment 3, specimen preparation and metallography of steel. Okay, specimen preparation and metallography is a vital part of physical metallurgy, since it allows us to infer the material form and its physical properties from its microstructure alone. A proper preparation of a metallographic specimen was to determine the microstructure outcome and content that required a rigid, step-by-step process that needed to be followed. Okay, these steps include sectioning, mounting, coarse grinding, fine grinding, polishing, etching, and microscopic examination. This specimen must be kept clean, and preparation procedure needed to be carefully followed in order to reveal an accurate microstructure result. For this lab experiment, each student will examine a few specimens for the metallographic examination result. This sample will be examined under a metallographic microstructure, and then photograph will be taken of the samples, and then the STM grain size number will be determined for each of the specimen if it applicable.
Hello, my name is Tang. I'm going to talk about the procedure for specimen preparation and metallography of steel. First, the small specimen has to be cut from the workpiece. When cutting the small specimen from the workpiece, the cool water is released to ensure specimen is as cool as possible. Next, the specimen is going to hot molding. Hot molding takes place under pressure in a molding press, where the specimen is placed in a cylinder together with the appropriate molding resin. A temperature of up to 200 degrees Celsius and a pressure of up to 50 kN are then applied during the embedding of the specimen. As the top surface is still uneven, the specimen is grinding until it is even. The water tap is turned on and adjusts the flow to obtain a good film of water. The specimen is lifted from the disc to determine the progress of grinding, but do not rotate the specimen. The 240 grit stage is complete when all the lines scratched in by the grinder are parallel on the specimen surface. If any line or scratch is not in the same direction as the other lines, continue grinding until all of the lines are parallel. When all of the sample scratches are parallel, carefully wash all of the debris from sample using tap water and dry the specimen immediately using a paper towel to avoid corrosion. The grinding steps are repeated by changing grit stage to 320, 400, and 600. When the 600 grit stage is completed, the specimen is ready for polishing. Before polishing, make sure that your specimen and hands have been thoroughly cleaned. The small amount of the aluminum oxide abrasive solution is applied to the disc. When polishing the specimen, hold it with both hands. Apply a moderate amount of pressure and don't let it go. Wash and dry both the specimen and your hands thoroughly, then rise the specimen.
The reference for my part is these two videos.
Hi, my name is Anak Johnson, and in this video I'm going to continue with the part of specimen preparation and metallography, which is etching and microscopic analysis. Etching is used to highlight and identify microstructural features of faces present. Etchants are usually dilute acid or dilute alkali 15 in water, alcohol, or some other solvent. Etching occurs when the acid or base is placed on the specimen surface because of difference in rate of attack of the various faces present and their orientation. The etching process is usually accomplished by merely applying the appropriate solution to the specimen surface for several seconds to several minutes. The specimen is immersed into nitrile solution. 5 seconds is usually sufficient for proper etching depending in sample and nitrile concentration. After that, immediately wash it under running water and then dry it in an air blast. After finish the specimen preparation, we move on to the microscopic analysis. First, place the specimen on the stage of the microscope so that its surface is perpendicular to optical axis. Metallurgical microscope has a system of lens so that you can adjust the lens so the different magnification can be achieved. After that, take a photograph of each specimen at the optimal magnification. Lastly, make sure that the specimen that you prepare is clearly labeled and the specimen surface is in its final condition. That's it for me, thank you.
Hi, my name is Lim Jia Jie. In this video, I'm going to talk about how to identify the phases of a specimen through microscopic examination. I will explain this topic by showing some examples. We can identify phases in a specimen by looking at its photomicrograph. For example, in this picture, there is alpha ferrite in it, which is the light phase portion of it. And there is iron carbide, which is a thin layer which mostly appears dark. From this, we can conclude that this is a eutectoid steel showing a pearlite microstructure. In this picture, here we can see again the light phase between the thin layer, that is alpha ferrite. And the thin layer, the dark thin layer itself is iron carbide. And there is a big portion of it, of the light layer, that is pro-eutectoid ferrite. So we can conclude that this is a microstructure consisting pearlite and pro-eutectoid ferrite. In this picture, the needle-shaped grains are the martensite phase, and the white region are austenite that fails to transform during the rapid quench. From this, we can conclude that this is a martensitic microstructure. In this picture, the small particles are cementite, and the continuous phase, which is the light phase, are alpha ferrite. From this, we can conclude that this is a spheroidite microstructure. Now, I'm going to talk about the purpose, or we call benefits, of the microscopic examination. Microscopic examination is an extremely useful tool in characterization of materials. Several important applications of microstructure examination are as follows. First, to ensure that the associations between the properties and the structure are properly understood. Second, to predict the properties of material once this relationship have been established. Third, to design alloys with new properties combination. Fourth, to determine whether or not a material has been properly heat treated. And lastly, to ascertain the mode of mechanical fracture. The reference for my part is a book called Callester, Fundamentals of Material Science and Engineering. That's all from me and my group. Thank you, madam, for lending us your ears.